Hello everyone, welcome back to our channel. By the way, thank you so much for all the subscribers. Now for this video lesson, entire week video lesson, we will have another competencies to discuss. So there will be 4 competencies that we're going to tackle in this week's lesson. The first would be illustrates a normal random variable and its characteristics. Number 2, identifies regions under the normal curve corresponding to different standard normal values. And the third one would be convert a normal random variable to a standard normal variable and vice versa. And the fourth one and the last would be computes probabilities and percentiles using the standard normal table. So I hope that you will be enjoying in this entire week's video lesson, and you will be able to complete all the activities as we go through with this lesson or group of lessons. And so, well, let's get started.
We're going to discuss about quarter 3 week 4, but in this video I have decided that we will just chop this into 2 instead of presenting the lesson for the entire week. We will just be discussing the first 2 days, so you won't get you won't have this so-called information overload. Okay, so in this case, we will just be discussing the first 2 competencies. The first would be illustrates a normal random variable and its characteristics, and identifies regions under the normal curve corresponding to different standard normal values. And that would be discussed during the day 1 and day 2. Okay, let's start with day 1. Now for day 1, the lesson objectives would be illustrates a normal random variable and its characteristics, constructs a normal curve, and develops perseverance and accuracy in performing various activities related to random variables. Now what is a normal random variable and what is its characteristics? So let's start with a pretest. So you are going to write this in your math activity notebook for this pretest answers. Read and analyze the statements below in your activity notebook or activity sheet. Write true in the if the statement is true, and write false if the statement is false. Okay, so make sure you're going to write this in your math activity notebook. So let's start with number 1. The total area under the normal curve is equal to 1 or 100%. Number 2. If the z-score is equal to negative 2.51, then the area of the region is 0.0060. Number 3. The area between the z-scores negative 2.0 and 1.56 is 0.9178. Number 4. If the area is 0.9332, then the z-score is 0.00. Number 5. Every normal distribution can be transformed to standard normal distribution. Number 6. The scores on scholarship aptitude exam are normally distributed with a mean of 72 and a standard deviation of 8. If the score is 60, then the z-score is negative 1.5. Number 7. The area between x is equal to 45 and x is equal to 62 of a given normal distribution with mean is equal to 50 and standard deviation is 10 is 0.9764. Number 8. The value of z in the expression probability of z is less than z, or the z value is less than z is equal to 0.0075 is 2.4398. Number 9. The rotation probability wherein z is greater than 1.81 is equal to 0.0351. Number 10. The z-score of 33rd percentile is negative 0.44. Okay, by the way, Again, this pretest can be answered only if we are done with the entire week's video lesson. So you gotta wait. You're just going to answer the questions here that is applicable or that is possible for you to answer after day 1 and day 2. But there are questions also that is intended for day 3 and day 4. So just leave it unanswered yet. Okay, so here we go. Okay, for a moment. So we have here the normal curve. Describe the histogram. What have you observed with this one? Okay, now graphs of continuous variables such as IQ, scores, heights, weights have histogram that have bell-shaped distributions. So you've noticed we have here a histogram, and then there's also a curve, and this curve, if we're going to describe this curve, this is a bell-shaped. So this is what we call the bell-shaped distributions. Okay, so when we are going to describe a normal random variable, so we have it here, the most important distribution in statistical science is a normal distribution, which has a bell-shaped curve. We have the following reasons. For letter A, many random variables are either normally distributed or at least approximately normally distributed. For letter B, it is easy for mathematical statisticians to work with the normal curve. Okay, take a look at this one. So that this is the graph, and that the graph depends on the two factors, the mean, or you have the symbol for the mean. It could be the small letter m, but we used to use this symbol, the population mean. This is the mu, and the standard deviation, the symbol. So it is how the mean and the standard deviation works or functions in a normal curve. So you have it here. So changing the mean shifts the distribution left or right. Look at this. Changes the distribution from left or right. So this is the mean. Because if the mean we're gonna change, so we can change it here or somewhere here. It depends. Then changing the standard deviation increases or decreases the spread. This one. So it could be steep or flat. If it depends on the value of our standard deviation. Okay, so let's recall first the three measures of central tendencies. So the first one, we have the mean. Remember that the mean represents the balancing point of the graph of the distribution. Then the second is the median. The second is the mode, and we have the third one is the median. The mode represents the high point of the probability density function. Example, the graph of the distribution. For the median represents the point where 50% of the area under the distribution is to the left and 50% of the area under the distribution is to the right. Now let us proceed to the properties of a normal curve. So the distribution curve is bell-shaped. Take a look at this. And this is our mean. So we have here 1, 2, then -1, -2. And then the curve is symmetrical about the mean. So remember, this is our mean. The curve is symmetrical. If you're going to fold it, if this is a paper and you're going to fold it, it will coincide. So it shows here that the mean, the median, and the mode are equal. So they're located here at the very center. And then the third, okay, you have it here. The mean, median, and mode coincide each other and located at the center of the distribution. Look at that. So meaning 50% of the distribution is below the mean, and 50% of the distribution is above the mean, or above the median and the mode. Okay, let's continue. Okay, next. Properties of a normal curve. The next property would be the normal distribution curve is unimodal. That is, it has only one mode. You know this, we discussed this already in our previous video. So take a look at this one. If you've noticed, this is unimodal, meaning there's only one value that has the highest frequency. Then it is asymptotic to the x-axis. Okay, asymptotic to the x-axis. This is our x-axis. And then when we say asymptotic, the curve approaches to the x-axis, same as here, but it will never intersect. Okay. Then the sixth property, the area under the curve is 1. So take a look at this one. So this is shaded, and this is the area. You have here f of x is equal to e to the power of negative x squared. That's Euler number. Or the area is of f of x is equal to the square root of pi. Then number 7, the change of value of the mean shifts the graphs of the normal curve to the right or to the left. Okay, this is our mean. So whenever it changes, so it might move the graph to the left or to the right. It will shift the graph to the left or to the right. It depends. Then the next would be the standard deviation determines the shape of the graphs. When the standard deviation is large, the normal curve is short and wide, while a small value for the standard deviation yields skinnier and taller graph. Take a look at this one. So this is an example of the skinnier and taller graph if the standard deviation is small. However, if the standard deviation is big or large, then it is spread out. So the normal curve is short and then wide, like this. Okay. Now constructing a normal curve, again we have this one, and the mean, median, and mode must be equal, and it's located at the center. And we got this empirical rule. So as the colored orange is, we have here 34% and 34%, a total of 68%. These are empirical rule: 68%, 95%, and 99.7%. Okay, and then 68% plus 13.5 and plus 13.5, meaning if we're going to add the orange colored area plus the green colored area, the answer would be 95%. Then if we're going to add the orange, green, as well as the purple colored area, the total would be 99.7%. Now what does it mean? So what does the empirical rule means? Okay, let's answer that one. So the empirical rule, it means that about 68% of the area under the curve falls within one standard deviation of the mean. And then about 95% of the area under the curve falls within 2 standard deviations of the mean. Nearly the entire distribution, about 99.7% of the area under the curve, falls within 3 standard deviations of the mean. Okay, and to understand this further, it's like this. Okay, since we say about 68% of the area under the curve falls within 1 standard deviation of the mean, so if this is our mean, so meaning the 68%, this is the area covered by the 68%, the shaded one. If you've noticed here, you got here the probability wherein x, okay, x is greater than the mean minus the standard deviation, at the same time less than the mean plus the standard deviation. That's left and right. And the area covered is 0.683. And then that area, if you're going to express that in percent form, that is equivalent to 68.3% or approximately 68%. Okay. Meaning you have here again, this is your mean, and then when you say about 68% of the area under the curve falls within one standard deviation of the mean, so you have the mean plus the standard deviation, and then the mean minus the standard deviation. Okay, let's proceed. Okay, here's the corresponding figure. So for about 95% of the area under the curve falls within two standard deviations of the mean. It means to say, if we're going to take a look at the normal distribution or the normal curve, you have this one, the shaded part, meaning this is your mean, and then mean plus 2 times standard deviation, and then mean minus 2 times the standard deviation. It means to say that is the area. The probability of the area if x is greater than u minus mean minus 2 times the standard deviation, but less than mean plus 2 times the standard deviation is 0.954. And if we're going to express that into percent, that is equivalent to 95%. Okay, let's proceed to the third one. Nearly the entire distribution, or about 99.7% of the area under the curve, falls within 3 standard deviations of the mean. So take a look at this normal curve. Again, this is your mean, and then this is the entire shaded area. The probability when x is greater than mean minus 3 times the standard deviation, but less than mean plus 3 times the standard deviation is 0.997, and expressing that into a percent form, so that is equivalent to 99.7%. Okay, so this is your mean, and this is your mean plus 3 times standard deviation, and then you have here the mean minus 3 times the standard deviation. You will understand this further in if we're going to do some activities later. Okay, let's start with developing mastery. You will have a sheet work. Now, I'll ask you to determine what is the frequency and relative frequency of babies' weights that are within the data has an average of 6.11 pounds and a standard deviation of 1.61 pounds. Okay. So you're given the mean, which is 6.11, and then the standard deviation is 1.61. You are asked to find or to answer this one, that what is the frequency and relative frequency of babies' weights that are within one standard deviation from the mean. Again, when we say one standard deviation from the mean, you are going to count the weights here in terms of pounds that will correspond to the values that is mean plus the standard deviation and mean minus the standard deviation. You have to solve first. Okay, like this one. You need to solve first mean plus the standard deviation given, and then mean minus the standard deviation given. So you're going to, within that you're going to get the values, or count the values within this intervals, okay? So again, you're going to count the number of observations under one standard deviation from the mean. Okay, for letter B, 2 standard deviations from the mean. So you are going to count the number of frequency again So when we say 2 standard deviations from the mean, so it will follow like this. So you are going to solve mean minus 2 times the standard deviation, as well as mean plus 2 times the standard deviation given. Then you count the number of frequencies that falls on that in between that description. Okay, then you're going to get the percentage afterwards. Okay, so that's your activity. You're going to write that in your activity notebook. Okay, now let us proceed to generalization. What are the properties of a normal curve? How is random variable illustrated? Then for the evaluation, for a moment, you're going to skip this one for a moment. And then we are going to take a look at your worksheet number 1. So you are going to answer. So you have it here. This is quarter 3 week 4 day 1. Worksheet number 1. Instruction, answer what is being asked in the situation. So the data below and the accompanying histogram give the weights to the nearest hundredths of a gram of a sample of 100 coins, each with a value of 10 pesos. The mean weight is 8.69 grams and the standard deviation is approximately 0.055 gram. Okay, so you have this for a moment, sorry. So you have that activity. So you have that activity. Okay. So you are given this data in this table. So I hope that is just clear. I'll make it bigger. So you can just screenshot that and copy that in your notebook. Take a look at that one. Okay. And then the following, we have also the histogram. This is the histogram. That's according to this data, based on this data. And here's the question now. So compare the mean and median. That's for letter A. Then letter B, what percentage of the data is within 1 standard deviation of the mean? Then within 2 standard deviations. Then within 3 standard deviations. Letter C, suppose you were to randomly select a coin from this collection, what is the chance that its weight would be within 1 standard from the mean? 2 standard deviations, 3 standard deviations. And letter D, what percentage of the data is below the mean? Letter E, suppose you were to randomly select a coin from this collection, what is the chance that its weight would be below the mean? Okay, so you are going to answer all these questions based on the data above. Okay, so it's similar to the activity that you have, the first activity in the developing mastery. So you are going to do the same thing. Okay, now let's go back to the PowerPoint presentation so we can proceed to day 2. So we're done with the evaluation for day 1. Let's proceed to day 2. Okay, I'll proceed to day 2. I hope you understand the concepts of the normal distribution curve or the normal curve. Okay, as well as the properties. So you have to familiarize the properties of the normal curve and the empirical rule also. Okay, that's very simple to master. Okay, and your assignment before we're going to proceed to day 2, write your answer in your notebook. Number 1, who is Abraham Demoer? And number 2, what are the steps in finding the area under the normal curve? Okay, thank you so much for listening for being attentive in listening our day 1 lesson. Now let's proceed to day 2. These are the objectives. Enumerate the steps in finding the area under the normal curve. Then, under the skills, identifies regions under the normal curve corresponding to different standard normal values. Then show self-reliance while working independently in identifying regions under the normal curve. Then regions under the normal curve. Okay. Enumerate the characteristics or properties of a normal curve. So we have here, remember, bell-shaped, symmetrical. The standard deviation determines the shape of the graph. And then this is asymptotic. The mean, median, and mode are the same. Change of value of the mean, meaning shapes of the graph. The area of the normal curve is always equal to 1, and the normal curve is always unimodal. Okay, you have to familiarize these characteristics. Okay, now let us proceed. This is your assignment before, and this is the answer. Now, history of the area of the normal curve. Abraham de Moir. He is a consultant to gamblers to determine probabilities, and studying the probability distribution coin flips and finding a probability of 60 or more tails out of 100 coin flips contributed the idea on normal distribution and probability theory. Okay, that is a brief background about Abraham de Moir. Okay, now Abraham de Moir in 1667 to 1754 introduced to us the formula to answer the question. We have here y is equal to 1 over the square root of 2 pi times the standard deviation e to the power of negative 1/2 times, by the way, this is already exponent, times x minus the mean over the standard deviation quantity squared, wherein this symbol is the pi, which is approximately equal to 3.1416, and this is the Euler number 2.7183, and this is the symbol for the standard deviation of the population, or population standard deviation, and x is the score in the distribution, and this lowercase Greek letter alphabet is population mean. Now, the standard normal distribution table values represent area to the left of the score. We have the so-called the Z table. Okay, by the way, each one of you should secure a copy of the Z table. I will be checking that by the next meeting. Okay, so this is, it means that the standard normal distribution table values represents area to the left of the Z score. So this is our X table, Z table, So steps in finding the area under the standard normal curve. First is you have to sketch the standard normal curve and shade the appropriate area under the curve. So you might be wondering, what is the purpose of those numbers? Later on you will understand. Okay, express the given Z score into a 3-digit number. Then look in the Z table and find the first 2 digits from the left at the leftmost column of Z table and third digit at the topmost row. So we have here, let's have an example. Example 1. Find the area when Z is equal to 1.4. The solution, the given says when Z is equal to 1.4, which means from negative infinity to 1.4. Hence, the shaded region is, okay, considering this is our normal curve, and here is 0, that is along the mean, median, and mode. And if this is our number line, so this is 0 until 3 here. Same is true with here, negative 3. So if it is 1.4, then that is located somewhere here. Then we're going to shade that part from the negative infinity. Remember, it is asymptotic to the x-axis. It will never intersect. So that's why we call it negative infinity. We don't know when it will end. Okay, it will just touch and touch the x-axis but will never intersect. So how are we going to solve this? So find the area when z is equal to 1.4. This is how you're going to use the z table. Now express 1.4 into a 3-digit number. So 1.4, to make it 3-digit number, since we have already 1, 2, we are going to add 0 on the last. So we have 1.40. In the z table, find the first 2-digit, 1.4, at the leftmost column. So this is our leftmost column. Then 0.00 at the topmost row. Okay. So 1.4 at the leftmost column, we are going to locate. So it's here, 1.4. And then since after 1.4 is 0, so we are going to use 0.00. Meaning, if 1.4 is added to 0.00, it's the same as 0. It is the same as 1.4t or 1.4. So this is now the area. Okay. Therefore, the area 0.9192 is now the area. So you're going to write it like this. Therefore, the area when z is equal to 1.4 is 0.9192, or the probability when z is less than 1.4 is equal to 0.9192, or you can write it in 91.92%. So this is now the normal curve, and you're going to write the area 0.9192. Remember, the entire area of the normal curve or normal distribution is 1. That's why it's almost 1. Okay, the shaded part. Let's proceed to the other example. Example 2. Now find the area between z is equal to 0.85 and z is equal to 1.18. Now the given says the area between z is equal to negative 0.85 and z is equal to 1.18. Thus, the shaded region must be like this. So, again, this is our normal curve. And then negative 0.85 is here. Because remember, this is 0. This is 1. So, that is after this negative 1. So, that is before negative 1 from the right, but after negative 1 from the left. 1.18 is here. Okay, now how we're going to do this? How we're going to solve this one? When we are asked to find the area between z is equal to negative 0.85 and z is equal to 1.18, it's different. It's a different question from letter and the previous one, because the previous one was very simple. Now this time it's just a little trick. Okay, so this is we are asked to find the area of the shaded region in between. So we're going to solve it. Okay, so as observed, that 2z scores is negative 0.85 and 1.18 are already expressed as 3-digit number. They are already 3-digit number. So for negative 0.85, find the first 2 digit, negative 0.8. So you are going to look at the leftmost column, that's negative 0.8, and next will be locate, that is negative 0.8. Then to make it negative 0.85, you will just add negative 0.05. Okay, so you will have 0.05 going down. So the answer, the area for with a z-score of negative 0.85 is 0.1977. So you were able to get it already. So this is now the intersection of the 2 points, negative 0.8 and then negative 0.05. So you have you have 0.1977. So we're done getting the area of negative 0.85. But remember, this is the area from the infinity to the right. Later on, we'll subtract. But we need to get first, we also have to get this one, the area of that z-score. So the same process, Moreover, for 1.18, we will perform the same process, that is, find the first two digit, that is 1.1, at the leftmost column of the Z table. Okay, where's 1.1? It's here. And then plus 0.08 because that's 1.1, and the given Z-score is 1.18. So what are we going to add from 1.1 to make it 1.18? So that is 0.08. Okay, so it's here. This is the intersection, 0.8810. So find the intersection. So we got it here. Now what are we going to do? So since we are looking for the area between the two Z-scores, we need to subtract the area that corresponds to Z is equal to negative 0.85 with smaller area from the area that corresponds to Z is equal to 1.18 with bigger area. Thus we have 0.8810 minus 0.1977 is equal to 0.6833. Therefore, the area between Z is equal to negative 0.85 and Z is equal to 1.18 is 0.6833, or the probability of the Z is greater when the Z-score is greater than negative 0.85 but less than 1.18 is equal to 0.6833. Okay, so in the normal curve, this is how you're going to look at it. So you're going to place the area 0.6833. Okay, let's proceed. Another example. So find the area to the right of Z is equal to 1.8. So it's another kind of problem. So we have to be very careful in analyzing the problem because not all problems are asking the same thing. So we have here, for a moment, not yet. Oh, sorry. This one. So we have here, find the area to the right of Z is equal to 1.8. Remember again our mean, that is considering that our mean is 0 and our standard deviation is 1. So we have this graph, and then of course this we are going to estimate where's 1.8 located. 1.8 is located. It's here. And then since we are asked find the area to the right of Z is equal to 1.8 to the right, so the shaded part or region would be this one, this part. Okay, so after that, the problem says to the right of Z is equal to 1.8, which means greater than 1.8, hence the shaded region is here. So we're going to solve this one. So this is how we're going to solve. Okay, it's hung. Okay, here we go. So express the given 1.8 into a 3-digit number 1.80. So in the Z, so you have here the leftmost column 1.8. So then we are going to add 0.00 because it's 1.80 if we're going to make it 3 digits. So here 0.9641 is the intersection, therefore that's the area. In the Z table, find the first 2 digit 1.8 at the leftmost column and the third digit 0.00 at the topmost row, then find the intersection of the 2 points 0.9641. Okay, always remember that the area of the entire normal curve is 1 or 100%, and the area of the Z table is from negative infinity to any Z score. Since the given says area to the right of Z is equal to 1.8, subtract the area that corresponds to Z is equal to 1.8 from 1. Thus, 1 minus 0.9641 is equal to 0.0359. Therefore, the area of the to the right of Z is equal to 1.8 is 0.0359, or the probability when the Z score is greater than 1.8 is equal to 0.0359. Okay, so that is how we're going to solve. So you're going to write here 0.0359. So this is the area. Okay, example 4. Find the z-score when p, probability of the z is less than the z-score, is equal to 0.7389. So it's another problem again. We are given the area, we are not given, and the z-score is unknown. Okay, so it's the other way around. So how are we going to solve this? Solution: sketch the standard normal curve and shade the region that satisfies the given. So we're going to estimate here. We don't know what is the normal, what is the z-score, but we're given the area, that is 0.7389. And remember, the entire area of the normal curve is always 1. Okay, always 1, and this is 50%, where with the 0 z-score here, that's already 50%. So of course it's 0.7389, so it's beyond 50%, so it's somewhere here. Okay, in this case we can directly use the z table and finding the z value, that is by finding given areas 0.7389. so we will just be looking at this one. Once found, identify the z-score. So we have here 0.7389. Okay, then after locating it, we're going to look at the z-score or z value. So the z-score to its leftmost column, we have 0.6, and then at the top most row, we have 0.04. Thus the z value is 0.64. Therefore, the z-score when p, probability z is less than z is equal to 0.7389 is 0.64, or the probability when z is less than 0.64 is equal to 0.7389. So it's here. So you will write here z is equal to 0.64 because that's the answer. Okay, I hope you were able to follow since the beginning. Now for developing mastery, you're going to answer this in your activity notebook. Find a z-score that will satisfy the given. Okay, you are going to find a z-score that will satisfy the given. The probability is negative 2.13 is less than z, less than z score, less than z, is equal to 0.2711. We are given here the area already, so we are going to solve this part. Okay, so I want you to explore, analyze the problem, use the z table, and solve this one step by step, and make sure to show your solution. Okay, so application. One reason the normal distribution is important is that many psychological and educational variables are distributed approximately normally. Measures of reading ability and introversion, job satisfaction, and memory are among the many psychological variables approximately normally distributed. Now, let's proceed to generalization. What is the formula in solving the mean, variance, and standard deviation of discrete random variable? How are they stated in the interpretation part? The mean, the variance, and standard deviation. Application. One reason the normal distribution is important is... Oh, we're done with this one. Sorry. So, let's proceed to the evaluation part. Okay. For the evaluation part, here we go. Let's skip that one and proceed to... Okay. So, we'll be going to this part. Okay. So, we are now on quarter 3, week 4, day 2, worksheet number 2. So, I will be reading the questions. So, answer the following questions in your activity notebook. The standard normal distribution, letter A. So, this is, you have to copy and answer. Multiple choice. You just have to encircle. The standard normal distribution, letter A, has a mean of 0 and a standard deviation of 1. B has a mean of 1 and a variance of 0. C has an area equal to 0.5. D cannot be used to approximate discrete probability distributions. Okay, number 2. If Z has a standard normal distribution and probability of Z is greater than 0 but less than Z is 0.3770, then the value of Z is it A 0.18, B 0.81, C 1.16, D 1.47. Number 3. True or false? The probability that a standard normal random variable Z falls between negative 1.50 and 0 is 0.7242. Number 4. Suppose Z has a standard normal distribution with a mean of 0 and standard deviation of 1. The probability that Z is less than 1.15 is blank. Okay. Number 5. Suppose Z has a standard normal distribution with a mean 0 and a standard deviation of 1. Okay, by the way, for a moment. Okay. Here, again for number 3, this is clear. Okay. This is clearer. Okay, for number 3, you have here the probability that a standard normal random variable Z falls between negative 1.50 and 0.81 is 0.7242. Number 4, suppose Z has a standard normal distribution with a mean of 0 and a standard deviation of 1. The probability that Z is less than 1.15 is blank. Number 5, suppose Z has a standard normal distribution with a mean of 0 and a standard deviation of 1. The probability that Z values are larger than blank is 0.3483. And number 6, suppose Z has a standard normal distribution with a mean of 0 and a standard deviation of 1.85. Of the possible Z values are smaller than blank. Okay, so you're going to answer this, copy and answer on your math activity notebook. Okay, so we're almost done. Now let's continue. For your assignment, answer in your notebook, what are the steps in converting normal random variable to a standard random variable? And how are you going to convert normal random variable to a standard normal variable? Okay, so thank you so much for listening our day 2 video lesson. And to end this video, let's have a quote. The only way to learn mathematics is to do mathematics. So thank you so much again for watching, and thank you for subscribing my channel, and please don't skip ads if you're watching this video. So bye.